So once again, welcome everyone to this webinar. It's an interesting topic for me in particular because, we have been hearing gist around AI collecting our jobs, and it's a bit scary. Yeah, we have been hearing gist around that, very soon though, developers, I heard of a case that a developer team of about 10 were shut down to like about 5 because now AI can do some of the work those developers do. It is scary. It is scary to know that AI can take your job, but then we still know that we humans still need to. AI cannot really do our work, right? We need to come to a term that AI is actually like for us as an enhancement, right? So in the light of all of those things, then we come up with a topic called Explainable AI, and we brought a phenomenal speaker to come talk about it. And Boris, Emeka Boris, I've known him since like 2020, is an amazing individual when it comes to AI and machine learning, right? Especially for that type of developer in Africa or in Nigeria specifically. So he's an amazing fellow in that field. So Emeka Boris has over 5 years of experience as a machine learning engineer, and he will be taking us through Explainable AI today. Because when I was like preparing for this, I'm like, we have been hearing a lot about AI, like who can explain this to us? Like, what does it do for folks that are not like deep into the tech parts? We want to know, we want to be sure that okay, AI is not collecting our, our jobs and all of those things, and every other insights Emeka will be dropping today. So please, with clap in the chats, thank you. With clap in the chats, help me welcome Emeka Boris. I'll be handing over to him right now. He will be taking us through Explainable AI. Hi, Emeka. How are you?
Yeah, hi, Bami, and hi, everyone. Welcome to the section. So, basically, I totally think that AI is definitely not going to take anybody's job. I mean,
Yeah, right.
I feel like the day, but at the same time, it's basically going to more or less be like an auxiliary helper to ease the flow. So imagine that you basically so just imagine if you don't have telephone, right? Like my iPhone, I mean, and you want to send message to someone, maybe your brother, you probably have to write a letter and then wait for like 3 days or so, and then you send it, and then you write, and then you send back to you, something like that. And then they invented telephone that you can get response instant. So that way you've noticed that there've been like a time optimization in the message or communication, right? So basically that is more or less like what artificial intelligence is going to do to every industry, right? It's going to more or less like optimize that it takes to achieve a work. So basically, yeah. So today we are mostly going to be talking about explainability AI, which is pretty much one of the most interesting topic in AI, because majority of artificial intelligence today is basically a lot of machine learning models that are out there, machine learning systems, where you basically either build a machine learning model using traditional machine learning model or deep learning or transformer kind of architecture, right? So just like you have your ChatGPT, you have your Cloudy AI, you have which other one again is popular? Which other one again is popular? The ChatGPT, Cloudy AI, U.com AI, and just pretty much a lot of amazing chat system that just out there today that people are like mind blown, starting from the amount of token it takes and the amount of token it returns. Like now we now have a lot of AI systems or machine learning models that take large input and be able to churn out or return large output. So I'm going to start with sharing my screen. Yeah, you can see my screen, right?
Not yet. I'm still saying yes, I can see it now. I hope, please confirm if you can see.
Sorry, you said something, you want to say something?
No, we can see your screen.
Just need to, I think I need to switch to all right. I guess you can see it now, right? Okay. Can you still see my screen? Just want to be sure. You can see my screen, right?
Yes, I can see your screen, Emeka.
Okay, great. So the most explainability AI, right? And one of the most interesting thing about explainability AI is basically you understanding what happened behind the scene, right? Let's say, for instance, you basically say, okay, how does ChatGPT basically take in a certain question, process it, convert it to embedding, and then run vectorization and embedding and all the behind the scene in transformer model, and then return the answer. You're basically curious, how it happens. You're more or less asking why did they make a certain decision. Question like, why is the result A instead of the result B, right? Question like in terms of context, why did it choose this kind of context instead of another kind of context, right? So now a lot of people come up and say, oh, they basically really like have no idea what's going on. They just like base or build their whole idea behind assumption, right? Based on, oh, it's just magic going behind the scene, right? So explainability AI more or less like focus on telling you that process that it takes to return a result, right? And basically telling you that AI is not basically built on assumption, right? It's more of a data model driven techniques, right? And then move over to the next part, which basically involve how it basically understand what particular features determine the response or the result of the model. So the next part would be a lot of people just believe that, like I said, in the absorption part, yeah, what did you predict for the data point? And it is like, oh, everybody's like, oh, we don't really know what's happened behind the scene, what factors, what features, you know, led to the model predicting that. So I think one of the most important thing I want you to know is what is explainability AI. So explainability AI is basically the process of understanding the model prediction at a data sample and basically at a level which allow like everybody to understand or to interpret the prediction and basically take action on them. So this is one of the how do I this is one of the way where human and AI that basically working hand to hand. I think they call it human and AI in the loop, or human in the loop, something like that. So it's basically a scenario where even with the response from AI, you basically want to understand how this AI basically make decisions, and if the decision is basically aligned with the traditional concept, right? So let's say, for instance, you're basically trying to classify between a dog and a cat, right? And a lot of attributes in a dog that is different from a cat. Things like the ear, things like the eyes, the nose, the nose, I think the foot, dog food. There's some dogs that have similar food with cat, maybe, but yeah, and there's just some similarity also, which is the fact that cat has 4 legs, dog has 4 legs. So you basically want to understand how or what particular feature this AI using to determine that dog is not cat and cat is not dog, something like that. So the next part would be we focusing on a business use case, right? Let's say, for instance, we basically want to look into a simple example in a business use case, or usually what everybody's used to, things like spam prediction or spam classifier. So let's say, for instance, you have like 2 messages, right? And I think I'll put this as an open-ended question, right? Just to hear everybody's point of view. So let's say we have you get 2 emails. The first one is, sir, I am wealthy widow, and if you help me pay 7 million USD, blah, blah, blah. And then best regard. The second email will be, Kelvin, this is a new term sheet of investors that open 7 million USD for 5% equity, blah, blah. So I think I want to ask a question now, more like an open-ended question. Within these 2 emails, which would you think is fraud and which is not fraud, but like which is spam and which is not spam email? So we have A and B, so you can just type your what you think, either user A or user B. Yes, definitely. So in conclusion, A is actually forward, mostly because so mostly because of context, right? And also so I just need to so mostly because I think this talk is distracting, but anyway, okay. So yeah, A is definitely spam or fraud email, mostly because of more or less like the context, right? So looking at the context, there is basically should I say, there is basically no alignment between being a ready widow and 7 million, right? Like you're basically saying, I'm a wealthy widow and I wanted to pay. Like, it's really like not a sentence where you literally tell somebody and they just bring that money and just give you. Like imagine if you just go to maybe CBN and just tell CBN, I'm wealthy, please can you help me pay $7 million for nothing? Like no like there's no intention, there is no objective, you just like, I mean, basically that would basically not happen in a real life scenario, right? But when you're basically looking at the email from user B, right, it's basically talking about from the email, you can just see that the context is focused more on, an organization willing to give an investor a certain amount of equity and they want a certain amount of fund from the investors. So we are going to say that user B is not spam and user A is spam. So now this is like the human logical thinking, right? And you know how the AI or machine learning basically trying to mimic the human reasoning to answer or make prediction or make decision making, right? So now we are looking at how we basically think, and then building a system that could basically mimic that thinking process and return a prediction or a decision based on that process, right? Now, we now have a logical reasoning on how we can decide if something is spam or not spam, right? And that logical reasoning is basically what we call the black box machine learning system, right? Or the black box machine learning model. So the black box machine learning model is basically referred to more or less like a model that are more like opaque and difficult for human to interpret. And then they focus more on the internal logic and decision process of most of the machine learning model, which is more like, how does this model make this decision, right? Is it following the traditional human reasoning? Is it just randomly making a decision based on random future? And then you also want to look into what is the transformation process in terms of the input and the output, right? So you want to understand if transformation process is more simplified, right? And then you also want to understand how what features and parameter in this black box system or this black box model basically determine the output. And last, you also want to understand how the model arrive on a certain prediction or decision. So looking at that, we basically now say, okay, how can we be able to understand these black box models? And black box models are mostly ensemble models, statistic, transformer, neural network, anything that has to do with mimicking the human reasoning system or the human reasoning process. Exactly. And basically, in essence, this is just like a typical machine learning system overall, where you have an input and then you take it through a black box system or model and then return an output. So now we basically want to understand, or the essence of this section is basically to understand the black box machine learning system, right? And moving on to the next one, we basically now want to understand firstly, why is explainability important? So XAI means like explainability AI, basically. So one of the reasons why we want to understand why model explainability is important is because we basically want to understand the reasoning, like I said, the reasoning process or the reasoning technique it takes to return the result. Exactly. So things like we also want to understand, why did they make a certain mistake, right? What parameter do we need to shift a little bit to be able to for the model to be able to return the kind of expected result that we look forward to. So we want to also understand, how can we trust the model decision? And if the model is biased, the bias is focused more on fairness and in terms of some futures bias, basically, and then understanding models and also why the model make decision. So we basically have been able to see why it is important. Now we also need to see, how does it work. Now there are various techniques used for explainability in machine learning system. And for most of these techniques, we basically need to understand how these techniques basically work, because in as much as you want to utilize the techniques that basically help you understand how the black box model work behind the scene, you also want to know, how does these techniques that help you understand these techniques actually work, right? Now, the techniques that we use mostly for evaluating black box model decision making is mostly done by basically so the behind the scene, or how it works, is basically you take in a certain perturb data set and then pass into your model, and then understand how your model basically, or return a result on how your model basically interprets this the input, basically, like or make decision in essence. So basically the explainability AI framework perturb data set, pass it into your model, tweak some similar input to see, okay, if I increase the ear of a dog, will it classify it as a cat? right? Or if I move the ear of a dog totally, will it classify it as a cat, or will it still be dog? So like what particular feature basically impact the decision of this machine learning model? So the next thing we are going to see is an example. Hold on, let me just get the example ready. Yeah, so let me share this other part of the screen. Um, that's my screen, right? So before I move into the example, does anyone that have any questions before moving to the example?
Is there any question? You can either use the chat or use the Q&A to ask questions. Yeah. It seems it's all clear.
Okay, great. So I could just need to run this. Just need to get this part. I think I'll just keep all of this parts. Yeah, just keep all of this part and all this. So yeah, so basically the aim of this is basically we are trying to basically see more like what particular transaction is basically going to be flagged by a transaction fraud system or a transaction or a fraud system in a bank. So this is the future selection part. And I will just skip this part here. Let's get this part. So for this section, I'm basically going to be using a traditional machine learning system, and the focus will be on using random forest classifier. So before we move into the explainability part, or more or less like seeing the major impact or the change in one future, or let me say a prediction result, what particular value determine that prediction result. Before moving to that part, we are basically going to be looking more or less at we're going to focus more on the future important. So future important is basically it's basically it's a result, or it's basically a process where you basically look for what particular feature in the model is very important in the result. So we're looking at more or less like overall prediction, right? So you have a sample test case, and then you run prediction on those test cases, and then you basically compute for the future important. So the future important is basically the average futures that basically, or the average value of a future that basically determine the model result in the test cases that you basically utilize. So we're basically going to be using this. I just need to make a little adjustment on this. This one. Oh, yeah, I think I've seen Netflix. So we're basically going to be looking at these. Okay, I think someone asked a question. Oh yeah, this is deep notes. So deep notes allow you to basically like I would say it's basically Google Doc, but for developers, because it allow like a real time collaboration. Yeah, so we basically have a set of values that we are basically predicting or we're looking to achieve. So this is more like a classification problem. And we have a lot of features that we use to determine if a fraud system is going to flag a transaction as fraud or not. Exactly. And we're basically using it to a multi-binary classification problem, which is actually true or false as the result. So is this transaction going to be flagged as fraud or it's not going to be flagged as fraud? And there are a lot of things we use to determine that. Things like the kind of card, things like the time you did the transaction, in terms of the hour of the day, the minutes of the day, is it a credit transaction, the amount, the country, the receiving country as well, the kind of device, and yes, shopping interaction, and has this transaction been flagged by maybe a fintech application fraud system. Either has it been flagged by has it been flagged as a fraudulent transaction or not. So we are more like building a verification fraud system. Exactly. So we can see that one of the most important features that really determine overall the important feature that really determine the result of the model is, or the prediction is, basically the amount, and then followed by the minutes of hour of the transaction. So let's say we are basically trying to understand, okay, why we've been able to understand that the euro amount or the amount basically determine you know, it had a lot of impact, basically. It had a lot of impact in the prediction result. Let's see, what if we try a single value, right? We want to understand based on single values, what particular future, what futures in general um, basically in terms of impact the model prediction. So let's go down to, I just need to, so for this particular project, I'm going to be using Line. But before I move into that, I will just talk about the various kind of framework you can use for explainability AI. So for this particular project, I'll be using LIME, which is the local interpretable model acognostic explanation. And the model acognostic part of it is one of the most interesting feature about LIME, because it helps you understand the should I say, yeah, not just the underlying distribution, but also understand the truth behind, a particular result from a model. Exactly. So we have various kind of framework for explaining the black box model. We have the explainx.ai, the XPQ, the Line, we have Sharp, interpretable ML, and Alibi. So majorly there's like a similarity between all of these features. So something like Explainx AI allow you to basically like, or give you that dashboard kind of view, which you can basically decide to like maybe set up on a server and then just be watching how your model make decisions based on the result. So let's say, for instance, you work for a company and then you basically want to see why you're monitoring your model drift and your data drift. You also want to see, okay, if my model is flagging these transactions as fraud, right? I want to see what major part of, or major feature in this data point decide that this transaction is fraud, right? And if you notice that, or maybe you want to evaluate a particular result from a model, right? And then you're like, okay, this person said this transaction was flagged as fraud and the transaction is not fraud. So I want to see what particular feature made my model decide that this transaction is actually a fraudulent transaction. So Moving to the next part, which is yeah, so we're basically going to install Lime, and then we are going to use the Lime tabular explainer, which is a method in Lime that allow you to basically explain based on the kind of model. So okay, so I think it's loading. Yeah, I think that the image is kind of loading, but I don't know why it's taking a lot of time to load. It's just, I think I need to like refresh this note again. I'm gonna just close this around. Yeah, I think it's actually a deep note issue. I don't know why it's not showing any result at all. Oh. Think that not just decided to film my house today. So I don't know why it's not returning any result here. You can hear me, right?
Yeah, I can hear you, Emeka.
Okay, great. So I cannot rewind this again. Yeah, great. So let me run this. Let me just run this. Oh, yeah. So basically, let's say for instance, we want to basically see, okay, for a transaction that actually happened, so let's see. Let me find one of the features. And then see this. Okay, let's do this one as example. Yeah, so let's say for instance, we are basically looking at a certain transaction, right? And we're like, okay, we want to understand what particular features really determine the model result of this particular model, right? And we're looking at a certain merchant, and we're also looking at some other features in our data point to see, okay, what particular features really determine or has impact on these results that this model actually predicts, right? And let's say, for instance, we also want to see the how do I say the behind the scene of this black box model for this prediction. So for this particular value, it basically flagged that this particular transaction is basically refused by ADN system, which means that it's basically flagged as a further transaction. And we're not saying, okay, what particular value or what particular features really determine, or what particular feature use or did this model use to determine the results, right? Firstly, we're looking at things like, is the transaction a credit? And mostly the result from these shows more like the prediction distribution, or let's say the probability rather. So the probability of each future's impact toward the model result, basically. So we can see from here that the fact that transaction is credit has a lot of impact in what the model used to determine that this particular transaction is fraudulent. And then the fact that it happened in the night hour of the day and the device type is one. The device type being one means that yeah, the Windows device. So, and then the it happened in the 14 minutes or 14 hours of the day. And these are more like the values it used or the futures it used to basically determine if the transaction is fraudulent or not. And then we can also see some other values that basically have impact in terms of what it used to decide that, okay, this transaction is actually true. So there are some of the values is like it has been refused before like a fintech system, the shopper interaction, and then the amount also. So from these we can be able to deduce that basically performing a transaction or maybe doing a transaction within a certain hours of the day, within a certain amount, and if the transaction is a credit transaction, within also the card scheme in terms of the kind of card that you use, and also within a certain minutes of the day can actually determine if a transaction is fraudulent or not. So like, and then we are basically saying that these transactions that we basically use as an example is basically fraudulent, and any transaction that is similar to, like these transaction values or data point will be flagged as fraudulent. So we are basically more like understanding or dissecting how this model basically make decisions. So these are like some of the features or how basically make decisions to determine if a transaction is basically fraudulent or not. And so this is more like the prediction probability, which is within the value of 0 and 1. So like based on the labels, right? So we have like 2 and 4. So if the probability distribution of true is greater than the probability distribution of false, then it's basically true, and otherwise or vice versa. So at this point, we basically have been able to more like see utilizing line to basically understand how this model basically think behind the scene, or the black box model think behind the scene. And I think one of the most interesting thing on why it's basically important for you to basically look into understand explainability AI, or more like put it into consideration and see the importance of it when you're building the machine learning system, is because there are a lot of regulation and law that basically guide individuals' data protection, or more like guide different continents, how people utilize their data. And also, you also want to be able to look into fairness and bias. So fairness is more like how your model basically return, or basically understand in terms of inclusion and diversity. So where everybody is treated equally. So the fact that the transaction is made at midnight and is done by a man should not mean that it's a fraudulent transaction. And the fact that it's done by a woman should also mean that it's a fraudulent transaction. Something like that that prevents false negative. Exactly. So looking into like some of the protections that actually guide people, and that's the reason why you also need to take into consideration explainability AI, is more like looking into laws. Yeah, so we look into like laws and regulation that basically guide people for explainability AI. And there are two common regulations that have been taken into consideration. The first one is the European General Data Protection Regulation. And then we in Nigeria also have like a general protection regulation. And one of the sections that really talk more about why explainability AI is important is, I think, is section 2, section 2 of the General Data Protection Regulation. We state that the data, or every individual, have the right to be given a clear information about the logic and significance of an automated system or data protection system that concern them. So as you're building, you should also understand how to make decisions, right? Because you also want to be able to tell somebody why you did not give them loan. So the reason why we do not give you loan is because blah, 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 blah. But another thing, or another reason why people always do not give out that information unless it's based on request, is because people can also find loopholes, right? Now that is where conscious about, if your model, for instance, let's say for this result, right? If, for instance, the reason why this model classify this result as fraudulent transaction is because it happened on the second hour of the day, is credit, and it happened on the second device and a certain minutes of the day. So what if I then decide that, okay, I don't want it to happen on a Windows device. I switch to maybe an iOS device. And then I decide that the minutes of the day, I'll do it during the day, maybe in the afternoon. Hour of the day, same thing. And then the card scheme, I'll probably like switch maybe from Visa to like MasterCard, that kind of thing. So like you're basically trying to perturb your data in order to tweak the response from the model. So it's basically like you trying to confuse somebody in order for the person to give you the kind of result you want. Exactly. So in as much as you're also following the general data protection law in order to understand how your model work behind the scene and give a clear explanation, you also need to be able to put model adversity into consideration rather. And yeah, so I think that is that. From this point of, I hope with this point of mine, I've been able to explain what the black box machine learning system is, and basically how to utilize line to interpret your model result, and also as well as convince you and not confuse you on the reason why you should actually put explainability AI into your model architecture. Thank you. So, do anyone have any questions?
Wow. Interesting session. Do anyone have any questions for Emeka? Please shoot away in the next like 5 minutes. Let's get it over with. That was an amazing session. Anyways, please, can you all give Emeka a clap? He has done so much to explain AI to us. And he's trying not to confuse us, but I hope I'm not confused. He's trying not to confuse us. He wants to convince us. So please, if anyone can still hear me, can you like drop clap? Thank you, Joel. Thank you. It was a wonderful session. And I think nobody has any question, as it seems. It seems everyone is understanding it. Am I going to take it like that? Okay. All right. So since we're like 2 minutes to the end of the session, thank you very, very much, Emeka. This was like a very, very insightful session. And I'm sure that it's going to, it's going to be useful because it's still going to our YouTube channel and a lot of people are going to be watching it afterwards. So thank you very much for the amazing session. We now understand AI. Oh, okay. All right.
Yeah, the slide and the example notebook.
Okay, yes, please. You can share that with me, then I'm going to share it with the rest of the community. I'm also going to share it via email to everyone so they will get to rewatch and follow the slide again. I think that will be helpful. Thank you very much, Emeka. Thank you so much. Okay, I think we already have a question, so let's just take that one question. And he's asking, how does one integrate this XAI with Google Dalon? Google Collab? Is that what you mean?
Yeah. So basically, I think that even though you really like behind a lot of things, it's also amazing that you actually like do more research on explainability AI. To be honest, explainability AI is more like, I would say, the easiest part of the whole process in machine learning architecture, because you basically I would say the easiest and the most amazing part of it, right? Because in as much as you're basically building, you also have the ability to understand, why it makes certain decisions. Now, that leads to the part where you basically now see that sometimes model accuracy does not determine model performance, So then another part is, so when I mean model, don't get me wrong, model accuracy is important. Model performance is, on the other hand, is important as well. But you need to understand that away from model accuracy, there are other model performance evaluation check, things like directional expectation test, inverse expectation test, inverse directional expectation test, inverse expectation test, differential testing. All of these kind of things are like model performance kind of tests, right? Then how does one integrate this explainability AI with Google Colab? Yeah, so I think it's almost the same thing with Deep Note. So you just need to do PIP install line or any of other explainability AI framework, and also just like when you're done building your model, you basically then pass in the model and the test case into the instance or the method that is basically used in the explainability AI library.
All right. I hope your question is answered, Joel. Thank you very much for this wonderful session once again. And this is like our vote of thanks. Thank you to everyone that joined and stayed put till this time. We all had an amazing time with Emeka. So and I'm seeing a lot of thank you in the chat. So thank you very much, Emeka. And this is the last one for folks that like joined later before, after my introduction. So I am Oluwabamikemi. Yes, he has shared the presentation. Oh, okay, shared with me. So let me just share with everyone. All right. So here is the presentation too. I'm still going to like send it to everyone via email and on Slack channel. So I am Bami and I'm the community manager for Tunga. And what Tunga, in a very plain language, what Tunga does is we connect African tech talent with international markets. So if you are a developer with over 3 years of experience, or you know a developer that is over 3 years of experience, that has over 3 years of experience, please kindly give them our website, tunga.io. I'm typing that again. Go to our website, tunga.io, and check out more information about us and how to join our developer community. You can also follow us on all our social media platforms. We have amazing sessions like this. Every month we have Instagram Live, we have webinars, and we have Twitter Spaces like this. We have career development events, boot camps, hackathons, and so on and so forth. So please follow us on Instagram at Tunga_IO. Follow us on Twitter at Tunga_IO, on Instagram at Tunga.io, on LinkedIn, Tunga.io. Follow us, and you'll be getting every information like Anthony. I think Anthony is one of our followers, and he joined this this session because he's following us on social media. So please follow us on social media. If you are not doing that already, you will be getting all the updates you need regarding all of our events and every other thing that we'll be sharing. All right, so you all do have a wonderful rest of your day, a wonderful evening or morning or afternoon, and enjoy the rest of your day. Thank you very much for joining. Do have an amazing evening. Bye.